What exactly is an earthquake? An earthquake is a sudden, often violent shaking of the ground caused by a rapid release of energy stored in the Earth's crust. This energy radiates outward as seismic waves. While millions of small earthquakes happen every year, most are so minor that only sensitive instruments can detect them. Major earthquakes, however, can be powerful enough to change landscapes, topple buildings, and alter the course of rivers. They are reminders that the ground beneath us is not as stable as it feels. The dynamic Earth beneath our feet. The Earth's crust isn't a single solid shell. It's broken into massive slabs called tectonic plates. These plates rest on the semi-molten mantle below, which slowly circulates because of the planet's internal heat. This movement drives the plates to shift, collide, or separate. It's a slow but unstoppable process. Plates usually move just a few centimeters a year, about as fast as your fingernails grow. But over decades and centuries, this motion builds up immense stress at their boundaries. When that stress overcomes the friction holding the plates in place, it releases in a burst of seismic energy, an earthquake. Fault lines, the cracks where energy escapes. Fault lines are the zones where most earthquakes originate. They are fractures in the Earth's crust where blocks of rock slide past each other. Normal faults occur where the crust is stretching and pulling apart. Reverse or thrust faults form in areas where the crust is compressing and pushing together. Strike-slip faults occur where plates grind horizontally past each other. The San Andreas Fault in California is one of the best-known strike-slip faults. Over centuries, stress builds up along these faults until the rocks abruptly slip. That slip, sometimes just a few meters, can release as much energy as thousands of nuclear bombs. Focus and epicenter, pinpointing the origin. The focus, or hypocenter, of an earthquake is the spot underground where the fault first breaks and energy is released. The epicenter is the point on the Earth's surface, directly above the focus. Although the shaking is strongest near the epicenter, the seismic waves can travel far beyond, affecting regions hundreds or even thousands of kilometers away. That's why a single quake can devastate entire countries. Seismic waves, how the energy moves. The energy from an earthquake spreads out in the form of seismic waves, and these waves come in several types. P waves, primary waves, the fastest waves, moving in a push-pull motion like sound waves. They arrive first, but usually cause less damage. S waves, secondary waves, slower but more destructive, moving the ground side to side. Surface waves. These travel along the Earth's outer layer and usually cause the most shaking and destruction. They roll the ground like ocean waves, toppling buildings and infrastructure. Understanding the types of waves helps scientists design better earthquake-resistant structures and develop more effective early warning systems. Measuring earthquakes. Magnitude versus intensity. To study and compare earthquakes, scientists use instruments called seismometers that record the waves. Historically, earthquakes were measured on the Richter scale, but today experts prefer the moment magnitude scale, which calculates the total energy released. Each increase of 1 unit on this scale means roughly 32 times more energy is released. For example, a magnitude 7 quake is far more destructive than a magnitude 6. Another measure, the modified Mercalli intensity (MNI) scale, focuses on the effects, how strongly the quake is felt, and how much damage it causes in different locations, where earthquakes strike most. Earthquakes are not evenly spread across the globe. They mostly occur along tectonic plate boundaries. The most active region is the Ring of Fire, a massive horseshoe-shaped belt around the Pacific Ocean where several plates meet. Countries like Japan, Indonesia, Chile, and the western United States experience frequent and often severe quakes. Other high-risk zones include the Himalayan region where the Indian Plate pushes into the Eurasian Plate and the East Anatolian Fault in Turkey. Even areas far from active boundaries, such as the central United States, can experience significant quakes when ancient faults reactivate, like the devastating New Madrid earthquakes of the early 1800s. Aftershocks, the unseen threat. After a major earthquake, the crust often needs time to adjust to its new state of stress. This can lead to a series of aftershocks, smaller earthquakes that follow the main event. While usually weaker, aftershocks can still be powerful enough to collapse damaged buildings or trigger landslides. In some disasters, such as the 2010 Haiti earthquake, aftershocks caused additional casualties and slowed down rescue efforts. Secondary hazards. More than just shaking, earthquakes often trigger other disasters that can be just as deadly. Tsunamis. Underwater quakes, especially those along thrust faults, can displace enormous amounts of water, generating waves that travel across entire oceans. The 2004 Indian Ocean earthquake unleashed a tsunami that killed over 230,000 people in 14 countries. Landslides. In mountainous areas, the shaking can loosen rocks and soil, causing massive landslides that bury homes and roads. Liquefaction. In places with water-saturated soil, shaking can cause the ground to temporarily behave like a liquid, undermining building foundations and leading to large-scale collapses. History's most powerful earthquakes. Earthquakes have shaped human history. The 1556 Shaanxi earthquake in China, with an estimated magnitude of 8.0, killed about 830,000 people, making it the deadliest in recorded history. The 1906 San Francisco earthquake at magnitude 7.9 leveled much of the city and caused fires that burned for days. The 1960 Valdivia earthquake in Chile, at magnitude 9.5, remains the largest quake ever recorded. The 2011 Tohoku earthquake in Japan, magnitude 9.0, unleashed a devastating tsunami and triggered the Fukushima nuclear disaster. These events demonstrate the sheer power of the planet and the need for ongoing preparedness. Predicting earthquakes, the ongoing challenge. Despite decades of research, scientists cannot predict exactly when and where a major earthquake will happen. They can identify regions at high risk and estimate the probability of a quake over years or decades, but not the precise timing. Modern tools, such as GPS systems that monitor ground movement and satellite data that detect subtle changes in the Earth's crust, help researchers understand the processes leading up to quakes. Yet earthquakes often strike with little or no warning. Preparedness, reducing risk and saving lives. While we cannot stop earthquakes, we can prepare for them. Countries like Japan and Chile have invested heavily in earthquake-resistant buildings, infrastructure, and public education. Simple precautions like fastening heavy furniture to walls, keeping emergency kits at home, and knowing how to drop, cover, and hold on can make a big difference. Early warning systems, which detect initial P waves and send alerts seconds before the more destructive waves arrive, have already saved lives by allowing people to take cover or for trains to stop safely. Earthquakes and the shape of the planet. Earthquakes are not just disasters. They are part of the natural processes that shape the planet. Over millions of years, earthquakes and tectonic activity have built mountain ranges like the Himalayas, shifted continents, and created new coastlines. This constant motion shows that Earth is alive and dynamic, a planet in perpetual change. The human perspective. Lessons from the past. Earthquakes test the resilience of communities. They expose weaknesses in buildings, emergency planning, and governance. Many nations have learned from past disasters. Japan's strict building codes and preparedness programs stem from centuries of experience with quakes. Similarly, California's regulations and public awareness campaigns grew out of lessons from the devastating 1906 San Francisco and 1989 Loma Prieta earthquakes. The more we study earthquakes, the better equipped we become to coexist with them.